In this lecture, we talk about searching algorithm, which is a fundamental algorithm for as called a linear search. Given a set of objects in the form of an array, the idea is to find whether a particular value is present in the array or not. Though it looks very simple, as the size of the array grows, it becomes a complex issue. So here we talk about only linear search, where it's in the primitive form. What it do is, starting from the first element, it matches with the key value. If it matches with the key value, then it returns the key is found and the corresponding location is returned. If it is not found, then the value is incremented further in the array, location value is incremented, and the key is matched with the second one. Like this, it sequentially tries to identify in the subsequent locations whether key is present or not. Once the key is present in a particular location, it returns the key value. If even after traversing the entire array, if the key is not found, it returns the key is not present in the array. So the algorithm very simply starts with the first element of the array and matches with that. If it matches, target is found, otherwise it moves on until the end. Here we see an example. We started with an array consisting of 11 elements, and the search key value in the first instance is 31. So the search starts with the first element in the 0th location, 10, 31 not equal to 10. So array is incremented, array value is incremented to 1, and the corresponding location, it has 51, which is not matching with 31. Like this, the array index keeps on moving, and the corresponding value is matched with the key. So incidentally, at the 5th array point or array location, the value 31 coincides with that, and the algorithm stops there. Now in the second instance, here is an example where the given key value is not at all present in the array. So in this case, the algorithm tries to check whether the key value is present in any of the places of the array. So the array index keeps on moving until the end, and once the array index reaches the end point of 10, then still the key value is not found. Algorithm stops and says the key value doesn't exist in the array. That's how it operates. There is a small variation of this linear search algorithm is called the transpose sequential search. A simple modification to the linear search is that once the key value is found, simply the element in its current location is swapped with the predecessor, only swapped with the predecessor. So now what is the advantage of this is, over a period of time, if several search operations are being performed on the array, and if a particular value is being searched more number of times, so each time the value moves to the predecessor location, so that over a period of time, what are the values which are being most searched will reach towards the left end of the array. The advantage of this is, whenever a new search is there on the same key value, it quickly identifies the existence of the key. So that is called the transpose sequential search. The only difference is, once the element is found, it swaps with the predecessor. So now what are the best case, what is the average case, and what is the worst case scenarios? Obviously, when the required key value is located at the 0th location or the first instance of the array, then obviously it is a best case, because in the first instance itself the value is being matched and the location is returned. That's it. And the worst case scenario is the value may be found at the last location of the array. That's a worst case. And the average case obviously is the key value lies in the middle. So these are the three types of cases that we can visualize in sequential search.